Hello my dears. In this lecture, I'll discuss the art of lateral thinking. That is, how to solve a multiple choice question without actually solving it. I have taken this example from JEE 2017 physics paper. It hardly matters whether you are appearing for engineering competition or a medical. You will find several questions which can be solved just using common sense, which is so uncommon nowadays. What I am going to do that I will solve this question as a straight line thinker first, and then I will solve this question again being a lateral thinker, and will leave it to you to decide that what approach you should take. Now, before I start to solve this question, let me brief you regarding the approach of a straight line thinker. A straight line thinker always works within the frame of the question. He never thinks out of the box. What actually he does, that his approach is completely traditional, and he first reads the question, then rereads it again, then think about the approach to solve the question, then note down the data available if possible, and then decide about the formulas which can ease his pain, and then solve the question meticulously. Remember, a straight line thinker solves a question within the frame. That is important, isn't it? Always within the frame, and he is very meticulous. He will go at a comfortable speed because he knows very well that life does not give you a second chance. I hardly believe in that, because life goes on throwing chances after chances at you till you grab one of your choice. But anyway, so first I am going to solve this question being a straight line thinker. Now, I will request you to keep a check on the time also. I am also keeping a check on the time. So now I start. Say the time is t equal to 0 now for me. I am starting to solve the question as a straight line thinker now. Start. I read the question. The moment of inertia of a uniform cylinder of length L and radius R about its perpendicular bisector I. What is the ratio L by R such that the moment of inertia is minimum? I reread it. The moment of inertia of a uniform cylinder of length L and radius R about its perpendicular bisector is I. What is the ratio L by R such that the moment of inertia is minimum? Okay, so how should I solve it? We are having a cylinder here. So let us say we are having a cylinder having certain length and certain radius. The question which is asked is L by R ratio. So I have to find L by R ratio. Now, what is the formula involved? Okay, about a perpendicular bisector, I know the formula of moment of inertia, and that is I equal to ml square by 12 plus mr square by 4. Now what to do? Okay, I can take m by 4 common, so I take m by 4 common. So I am left with L square by 3 plus R square. Now, there is a condition here, that is minimum. So naturally I will go for maxima minima. So I will have to differentiate this and equate this equation to 0. But the problem is I am having L and R, two variables here. So either I will have to put R in terms of L or L in terms to R. So what to do? Okay, density is mass by volume. So or this implies mass is density into volume. So let us say mass volume of a cylinder will be pi r square L. Let us say the density is rho. From here I take out r square and I get r square equal to m divided by pi L rho. This value I am going to put here. So I equal to m by 4, then I am having L square by 3 plus r square is m by pi L rho. Now I can differentiate it and equate it to 0. So I find di by dl, that gives me m by 4. Here I get 12 by 3, if L is in the denominator, so I get minus m by pi L square rho. I equate this to 0. So what I am going to get is m by 4 into 12 by 3 minus m by pi L square rho is equal to 0. This gives me 12 by 3 equal to m divided by pi L square rho, or this gives me 12 by 3 equal to m pi rho. So naturally m by pi L rho is r square, so I put it here, m by pi L rho, so 1 L is gone. So basically I land with r square by L. Now here I am getting 2L square equal to 3r square, or this implies L square by r square equal to 3 by 2. This gives L by r as root under 3 by 2. So this option is correct, root under 3 by 2. This I solved it being a straight line thinker. I took almost 4 minutes to solve this question. Okay, see, this is how straight line thinkers solve a question. Now, the same question I will solve as a lateral thinker. Remember, lateral thinker always thinks out of the box. When he reads a question, his focus is to get hold of the clues which can ease his pain. He is least bothered about the formulas involved and all, isn't it? He is more interested in eliminating the options rather than solving it completely. So now I will solve this question as a lateral thinker now. Let us start the time again and say again it is time t equal to 0. So I start. I read the question. The moment of inertia of a uniform cylinder of length L and radius r about its perpendicular bisector is I. What is the ratio L by r such that the moment of inertia is minimum? These options are given. L by r ratio is what? Grabs my attention immediately. If we are talking about the cylinder, which is here, the ratio L by r, if we are talking about it, then you can easily make out that if it is a cylinder, then the length of the cylinder must be greater than the radius. It means this L by R ratio must be greater than 1. Okay? So simple, see? L by R ratio must be greater than 1. That is for sure, if you are talking about a cylinder then. Now, if it is greater than 1, then option 1 is a straight way out. It cannot be the answer, isn't it? Now I try to solve. What are these options? This is 3 by root 2. So 3 divided by say 1.4, that gives you 2 point something. So it is basically greater than 2. Root 3 by 2 is root 3 by root 2. That gives you 1.7 divided by 1.4, shows the 14, isn't it? So it is 1 point something. Root 3 by 2, again that is 1.7 divided by 2, that is less than 1, a straight way, isn't it? So option number 4 is also out. Naturally, either it is option number 2 or option number 3. Option number 2, we are having a result which is greater than 2. Option number 3, we are having a result which is greater than 1. As per our analysis, L by R ratio must be greater than 1. So either this option is correct or this option is correct. Since the condition here is minimum, so we go for the minimum one. So naturally, we go for root 3 by 2 over. I hardly took 1 minute to solve this question. And I never used any formulae whatsoever, isn't it? See? Now, remember, a straight line thinker is the prisoner of his own thoughts. So if you are one, then my advice is to change. A lateral thinker can easily change the mode and get into the shoes of a straight line thinker, whereas it is extremely difficult for a straight line thinker to change gear and become a lateral thinker. Now it's up to you, isn't it?